Hi everyone, I am Srishti, and in today's video I'll be talking about sets. I'll be starting with certain basics and then going into the detail, and finally I'll be talking about set comprehension and certain set functions. So in Python, a set is an unordered collection with no duplicate elements. There are two keywords which we must keep in mind over here. That is, the first is the unordered collection, and the second one is no duplicate elements. And it is these two characteristics of a set that distinguishes it from the other kind of containers that we have already studied. So let's look at these two characteristics in detail in this program. What I've done here is that I have declared a list that's a basket, and I've put certain fruits into them, that is banana, and there are two bananas, then three oranges, and an apple, mango, and grapes. And finally I have used the set function to create a set which is called fruits in basket, and I have printed it. And I've also used a for loop, so you can use for loops on a set. I've used a for loop to print these fruits in a slightly better way without the word set and these brackets coming into the picture. So this is how this is going to look like. So we can clearly see that the set does not contain any duplicate elements. In spite of having 3 oranges and 2 bananas in the basket list, we have only 1 orange and 1 banana element in the set. So set has no duplicate elements. Secondly, banana was the first element in the list basket, but in case of set, orange is the first element. This shows that set is an unordered collection. So Python is going to print these elements in some order which might not be the same as the one we had put into our program. Now I make a slight change in the for loop that I have over here. What I'm going to do is that I'm going to try and index sets, that is for I in range. Now I know that it contains 5 elements, so I put range 5 over here. And what I'm going to print are these elements that are present inside this set. And let's see what happens. So I run this and I have a type error that says set does not support indexing. So that is another property of set, that you don't have indexes. And since it is unordered, it is quite reasonable. You would never know that what is present at the ith index. Since it is unordered, anything can be present and Python only knows about it. So we have to keep in mind that set does not support indexing. So we have already seen that it is the set function that is used to create a set. So I'll just play around a bit more with the set function, and let's see what all can be passed into the set function. In this first piece of code, I have a list of numbers which I'm passing, 1, 2 and 3, and finally A. A is a variable to which I have assigned the value 3. So just let's run it, and it says value error expecting array or iterable. So we cannot pass a bunch of numbers just like that. We need to put it into a list to pass those numbers into a set. And whatever we are passing into a set, it needs to be an iterable. So obviously we have seen that this does not work. Next, what I do is I passed a boolean value, and seeing the previous error, we can just expect that we are going to get an error again. And we get an error again because this is a boolean value and boolean values are obviously not iterable. Next, I pass a dictionary. Now dictionary is iterable, but let's see what gets printed. So we see that when we pass a dictionary into the set function, it is the keys that become the element of the set. Next, I pass a string over here, and when I run it, I can see that the string is an iterable, and these string elements, they get passed into the set. So the set contains the alphabets P, Y, T, H, O and N. Now what I do in the next piece of code is pass a tuple. So when I pass a tuple, I can see that it gets passed, and we have 2, 3 and 4 which gets printed over here. Now I pass a set into this last test set 6, and I run this, and I see that both the sets, they get printed, test set 5 and test set 6. Now set 6 is completely different from set 5, and it just so happens that they both have the same elements. Next, let's explore that what kind of elements can a set have, mutable or immutable. One thing that I want to bring to your notice before I start is that in each of the set functions that I have declared over here, it's a list which is being passed, and it's the element of the list which are different. In the first case, it's a dictionary, then it's a list, then it's a tuple, and so on. So everywhere the set function has a list which has been passed as a parameter. So we run the first set which has, if it runs, will have dictionary keys as its element. So I run it and it creates an error. So this is because it's actually a mutable type, and that is why it cannot be put into a set. So sets cannot have any mutable elements. So let's uncomment all the codes where I have passed mutable elements into the set and check if what I'm saying is true or not. So list we know is mutable and it creates the same error. Now we can expect test 3 and test 4 to be created successfully, as the test 3 has tuple as its elements and those are immutable, and strings are also immutable. So I run this and I have 2 and 3 in the first set, and the second one I have Python, which is a string. Lastly, I check the same for an object. So I've created a class over here which has an element x, it has an attribute x, and I also have a str function which is going to print this. And I've created two objects out of that, a1 and a2, and these objects have been passed into this test 5, and I run this. So even this is successful, and the set contains two objects. The first object is this and the second object is this. And when I print the elements of the set, that is basically the objects, these get printed successfully, 2 and 4. The printing takes place with the help of the str function. Now let's look at set comprehension. So like list, set comprehension is also possible. And in this particular program, I have a basket just like the one I had in the first program, and it contains certain fruits. The next, I have another set which is fruits starting with G. And over here, I have used a set comprehension. So when you're using a set comprehension, you have to use the function set. And you can just easily compare this to a list. In a list, we had to put the two square brackets because those were the brackets that used to indicate that now we have a list over here. And since in case of a set, we have the set function which indicates that a set is going to start. So I am using a set function over here. Inside the set function, what I have is x for x in basket if x0 is equal to g. So I already know that this basket set, it contains strings basically. So what I do over here is that I check whether the first element of that string, the first alphabet, is it equal to G? And if it is equal to G, then put that element of that basket set into fruits starting with G set. So I run this and I print this set and I have grapes and guava printed. So that is true, they both have G as their first alphabet. I can just test this with M. So I just make this M and I run this and I have mango, melon and muskmelon printed. So this is how the set comprehension works. Now in this last program, I'll be talking about certain set functions such as symmetric difference, is subset, is superset, etc. But before I start talking about them, let's just revise what all we know about these functions for sets. So let's go through this quickly. First, I have A union B. So A union B has elements which are present in both A and B. Next is the intersection of A and B. So it is going to have only elements which are common to both A and B. Then there is A minus B, that is the difference. This will contain elements which are present in A but not present in B. Then we have the concept of subset and superset. So A is a subset of B because all the elements of A are present in B. And in this case, B is known as the superset of A. And then I have the symmetric difference of set. So set of elements which are in either of the set and not in their intersection are going to be in the symmetric difference. Now let's just see a very quick implementation of these basic set functions in Python. So I have three baskets which contain some fruits. I print these baskets using the print statement. Now the set symmetric underscore difference is going to contain those elements which are present in exactly one of these two sets, that is basket 1 or basket 2. So the elements which are present in exactly one of these two sets are going to be present in the set symmetric difference. Then I have is subset function. So according to this line, it says that basket 3 is a subset of basket 1. So if that is true, then it is going to print true, else it will print false. Similarly, I have basket 1 dot is superset basket 3. So if basket 1 is a superset of basket 3, then I'll have true over here. And finally, I have difference underscore update. Now you can see over here, I have not returned the value of this function anywhere because this function does not return any value. It simply updates basket 1 to contain those elements which are present in the difference of basket 1 and basket 2. I run it and we can see that these are the three sets that I have: basket 1, basket 2, basket 3, and these are the elements inside them. First, I have the symmetric difference. So the symmetric difference of 1 and 2. Basket 1 and basket 2 contains orange, banana, apple and pineapple. And then I say, is basket 3 a subset of basket 1? And that is true because all the elements of 3 are present in 1. And next is basket 1 is a superset of basket 3. So that's just another way of saying basket 3 is a subset of basket 1. And that is again true because all the elements of 3 are present in 1. And lastly, I update basket 1 so as to contain the difference of basket 1 and basket 2. So basket 1 contains orange, banana, apple, mango, grapes, and 2 contains mango, grapes, pineapple. So their difference is orange, banana and apple, and that is what gets printed over here. So we went quite deep into sets over here. I hope you found it useful and thank you for watching this video.